All right, students, welcome. I don't know how you're faring with all this social distancing, but I know it's been a challenge. Um, Thank you for all the work you're doing. You know, we're trying to continue your education, give you a quality education in the midst of all the craziness, and hope that the videos are helping you to do so. Just a couple things before I get into the review. Um, Remember, if you have trouble with your printer and it's a quiz or a test, you can simply treat it like a homework and use the PDF that you're looking at on your screen as the original, copy the original problem down, show your work, write the answer, turn that in. That will work for any quiz or test. I'll also have copies of those at the school. That'll be a little bit more challenging to try to make it work out. When we do have a quiz or a test, I'll email that quiz or test by 9 o'clock the morning of the quiz or test. And then what I'd like you to do is just sometime during the day, have your parent proctor that test and have you take that test, maybe at the kitchen table, something like that. Complete the test or quiz that day and then email it to me. Quizzes, I'll definitely need by the end of that day. The test, if for some reason it takes an extra day, that will work out, but always within 2 days. But the quiz I'll need by the end of that day because the following day I will send you out in the morning a review video of that quiz explaining each problem and the answers to them and helping you that way, all right? Because we still want to have class, we still want you to learn. That's what this video is all about as well, right? Here I'm sending you a video now of the homework, the review questions, and therefore this video will help you to understand what's going on. By the way, with the notes going forward, next chapter's notes, I'll have them copied and sitting at the front desk in a folder. If you have trouble with your printer at home and you need to come by and pick up a set of notes, they'll be available for you here. I'll also have them on the portal and by email in a PDF that you can print out yourself if you want to do that. All right, so all that's available. How are you going to use this video? Well, if you go on the portal and you'll look at your grade, and then click the comments. The comments are going to tell you the problems that you missed. Do you need to watch the whole video? You can. Do you have to? Not necessarily. You can simply go to the problems that you missed and watch those problems. If you feel like you need more help, watch the whole video. Hopefully it'll be help for you. We are toward the end of the chapter here and are getting ready for quiz and test next week. So hopefully this will set you up for that and help you in that, and hope it'll be a blessing to you. All right, let's get into it. All right, so 1 through 4 says, simplify the following. If no answer exists, state not real. Now, you could just punch these in your calculator, and that's going to be the idea on something like this, because all of these work just exactly the way they are. So the square root of 196 is 14 because 14 times 14 is 196. So that was number 1. Number 2. Whenever you have an even root, remember the index is not shown, but it's a 2. That's an even root of a negative radicand. There's no real number. So this is not real. I think is the way, yeah, it says right, not real. Here again, you have an even root of an odd radicand. That's also not real. Now in this one, the negative is outside, so that's not a problem. That negative stays out. And then what is the square root of 16? 16 is a 4 times 4. Anything times itself, the square root is it, and so you get a negative 4, and that's 1 through 4. By the way, any questions, you can always email me. I'll answer your questions. Hey, just so you know, us teachers, we're working hard pretty much every day. We're working to get you content, to grade your answers, and to give you stuff. So email me and I'll get back to you and we'll try to help you out. Okay, 5 through 8. Now we've got a little bit more involved. You'll need to pay attention on these. A few of you missed some of these. So on number 5, you should have looked at this and added up the 25 and the 144. You must do it this way and get the square root of 169. If you know that's a 13 times a 13, the square root of anything times itself is that number 13. Number 6 should have looked like this. So when you did the square root of 121, you should have gotten an 11, right? Because 11 times 11 is 121. On the bottom, when you took the square root of 36, you should have gotten 6. This is the work I should have seen on your paper. And then you should have reduced, right? 2 and 3. And this is how you end up with 22/3. All right, so be careful there. This is the kind of stuff I'm looking at your paper to see if you're understanding. Okay, number 7. You need to add this up first. So 25 minus 16 is what, a 9. All right, what is the square root of 9? It's a 3, but notice we have this 2 in front, so that's a 2 times 3. We've got our plus sign, and what's the square root of 81? 9 times 9, right? So that's a 9. Notice how we have 6 plus 9 is 15, and that's why number 7 was 15. Number 8 can be done 2 ways. Most of you are just going to multiply this out, and you're going to get 4 times 36, what's 72, 144, and the square root of 144 is 12. All right. Because things are multiplied, you could have split it up and said the square root of 36 times the square root of 4. Notice what happens. Square root of 36 is 6. The square root of 4 is 2. And see how you also end up at 12. Now that only worked because they're multiplied. That does not work here because they're added. It does not work here because they're added. Only when they're multiplied. But you could do it either way. All right. Let's continue on. 15. So equations. So we're going to isolate the rad, right? ISO the rad, ISO the rad, ISO the rad, add a 5 to both sides. Sure enough, we get the square root of x equals 3. Now at this point, we know to square both sides. Squares undo square roots. We get x equals 9. There's our answer we're rolling on. Now on the second one, it's already isoed. So we're going to square both sides. You're just going to take your calculator and you're going to do 1.7 squared, and what is that? 2.89, right? And 2.89 is the answer to number 16. All right, number 17. Remember, move things added before you move things multiplied. Remember, this is what we're isolating. ISO the rad. So add a -9 to both sides. This is the work I should see on your paper. We still have the 3 times the square root of 2x equals -9. Divide both sides by 3. Now you have the rad isoed. And so we have -3. And it's at this point that we're going to look to square both sides. But remember, when you go to square, if you have a negative, no real solution. Because you can't take the square root of something and get that negative. That's the issue. Okay, so no real solution for 17. 18, again, we're going to iso the rad. There's only something multiplied times the radical, so we'll multiply by the reciprocal or do the shortcut. And we got the square root of 4x minus 3 all underneath the radical sign. Let me make that 3 look a little, boy, that's not better, is it? All right, let's fix it. Here we go. Hate to take the time, but it was so ugly. All right, and we have equals 3. Good. Our radical is isolated. We're ready to square both sides. Squares undo square roots. We have 4x minus 3 equals 9. Now we have to isolate the variable. Move things added first by adding their opposite to both sides. Move things multiplied by multiplying by the reciprocal or doing the shortcut, dividing if it's an integer. And we get x equal 3. And there's our answer to number 18. All right. So these are key. This is really one of the more important things of this chapter is being able to solve radical equations. Next, now we got to do it the other way. We have quadratic equations, the variable squared, and we got to get back to the radical. All right. Now pay attention to the directions. If no answer exists, state no real. And it says in simplified radical form. Simplify. This is where some of you didn't complete the problem, so pay attention. I'll show you what to do. Okay, we have to isolate the squared term. So that means I got to move that 31, add the opposite to both sides, and what do we end up with? X squared equals, all right, what is that? 81. So I was going to say 83. All right, now we're ready to take the square root of both sides. And some of you have already forgotten. Remember, whenever you take the square root of both sides, don't forget the plus minus. You can't forget that plus minus. All right, square roots undo squares. We get x. We should all know the square root of 81 is 9. That's why 19 was plus or minus the square root of 9. Number 20, iso the squared term, divide both sides by 7. We get x squared equals 8, right? Take the square root of both sides. Don't forget the plus minus. Now look where we're at. This is, oops, that's an x. X equals plus or minus the square root of 8. Now you have to say to yourself, does the square root of 8 simplify? Yes. So how do we do that? Sorry about that. So to simplify the square root of 8, let's factor it. 2 times 4. Can you take the square root of a 4? Yes, it's a 2. That 2 comes out in front. So here's what we have left. X equals plus or minus 2 times the square root of 2, right? That green 2 is out front, and that red 2 is still inside. Follow? And that's your answer to 20. All right, 21. Add a positive 1 to both sides. Now we have x squared over 3 equals 12. All right, remember that 3 is like a 1/3. You got to multiply both sides by the reciprocal. Doesn't that allow that 3 to divide out? It's been a while since we did those, but again, that's our main thing with equations, right? Multiply both sides by the reciprocal. All right, so we got x squared equals 36. Take the square root of both sides. Don't forget the plus minus. And this, by the way, this is what I should see. In your work, that plus minus should be right there. It doesn't reappear here. It should be on the previous step when you take the square root of both sides. All right, and that's a 6, and there's our answer there. And did we do number 22? I believe we did. Okay, so again, let's add a negative 12 to both sides as we're going to isolate the squared term. 4x squared equals negative 4. Divide both sides by 4. We get x squared equals negative 1. And look what happens when you go to take the square root of both sides. Can you have the square root of a negative number? No. So, no real solution. No real solution. And on you go. All right, so 19 to 22. Again, you should be able to solve these equations. What's the biggest mistake students make? They forget the plus minus. Don't forget the plus minus. All right, what else? 23 and 24. Given the lengths of legs, the hypotenuse of the following right triangle, simplify irrational roots. All right, so Pythagorean theorem. C squared equals a squared plus b squared. And you have to remember that this is the hypotenuse. So that's what we're looking for. So formula, c squared equals a squared plus, I should have seen this on your paper. And I should have seen c squared equals 15 squared plus, what is the 8 squared? And you could do the c right now or just leave it c squared. 15 squared is 225. 8 squared is 64. C squared equals, add those up, 289. And do you see now how you're ready to take the square root of both sides? Now, it's the Pythagorean theorem. Do we include the plus minus? No, because when you have a right triangle, if one leg is 15 and the other leg is 8, this leg has to be positive. You can't have a negative side of a triangle. And for that reason, on Pythagorean theorem, we don't include the plus minus. Okay. Punch that in your calculator, square root of 289. I'm going to punch it in right now. Come on, calculator, 289, square root 17. And 17 units. If it were feet, it'd be feet, whatever it is. Okay, let me do 24. Same thing. Start off with my formula. I can cheat a little, right? And now I'm going to sub in my values. What is my A? 5. What is my B? 5. See, this is how your work should look, right? Now notice we're at c squared. Take the square root of both sides. Do I do the plus minus? No, because it's a triangle and the side of a triangle can't be negative. But can I simplify the square root of 50? Yes, and a lot of you did not. A 50 is a 2 times a 25. Can you take the square root of 25? Yes, it's a 5. So your answer should have been 5 times the square root of 2. Does that make sense? I hope it does. Pythagorean theorem. Again, another major key thing in this chapter. You've got to be able to do Pythagorean theorem problems. Okay, so now we need a leg. So Pythagorean theorem again, c squared equals a squared plus b squared, right? One formula. Watch how we use it. I'm just going to copy it and bring it over. All right, so let's do it for 24, for number 25. All right, so in this situation, I know that, okay, 34 and 30. Now, how do I know 34 is the hypotenuse? Remember, the hypotenuse is always the longest side, always the longest. So the 34 has to be the C, because they told us one of them is the hypotenuse. You could solve for A or solve for B. It doesn't matter either way. Here, I'll look for A. You could have looked for B. That means the B is the 30. All right, 34 squared. I'm just going to punch that into my calculator. 34 squared. 1156. This is the way your work should look. 30 squared. Was that 900? I'm going to check myself. Yeah, 900. All right, equation. Add a negative 900 to both sides. This is what your work should look like if you're really understanding. All right, 1156 minus 900 is 256 equals a squared. Now we're ready to take the square root of both sides. It's a triangle, so we do not do the plus minus. Punch in your calculator the square root of 256. Oh, and lo and behold, it's an even number. It's 16. There's our triangle. Next one, again, start with the Pythagorean theorem. It just separated all that stuff with me. Come on, move. No, move. There we go. Got to talk to it. Sorry, guys. All right, and again, I know my C is the 6, the bigger one. Now this time, I'll put the 3 in for the A. Again, I can do it either way. A and B are interchangeable. Does not matter. You can't mess that up. All right, 6 squared is 36. 3 squared is 9. Equals b squared. Again, this is what your work should look like. Add a negative 9 to both sides. 25 equals b squared. Now take the square root, right, of both sides. And the square root of 25 is 5. And there's number 26. Got to be able to do these problems. Very important. All right. Remember to verify. Once again, you're going to use the Pythagorean theorem. C squared equals a squared plus b squared, right? By the way, it's also a squared plus b squared equals c squared. Either way, when you're solving for the hypotenuse, it's easier putting a c in the front. Either way, it works. Boy, I'm going to do it the other way on this one just so you guys get the idea. So here, I'm going to do it this way. All right, so remember, the biggest number has to be the C. So that's got to go there. And again, A is 10 and B is 25. All right, punch in your calculator. 10 squared is 100. What's 25 squared? 625. And what's 27 squared? 729. Oh, I get 725 does not equal 729. That's a no. They have to equal, right? Pythagorean theorem, they got to equal. If they equal, we're good. If they don't, we are not. And therefore, then, we are not. Okay. All right. Other one. So, Pythagorean theorem, the 34 has to be the hypotenuse. Oh, I'm doing that one. No, I'll do it that way, right? Either way it works. 34 squared equals the A, make the A the 16, make the B the 30. All right, calculator, 34 squared, 1156, 16 squared, 256, 30 squared, 900, 1156 equals, oh, look at that, 1156. Yes, it is a right triangle. Okay, got it? Again, important stuff here. Now, the last few is where we need to be careful to make sure that we understand what's going on. Now, let me see, make sure. I gave you 28, and then we went to what? 31. Simplifying. All right. You got to be able to factor these things to simplify them. I'm looking for two of the same factor. 252. I'm going to go 2. So 2, just use my calculator. 252 divided by 2, and I get 126. Okay. So now let's do 126 by 2. So again, on my calculator, that 126 is still there, and I'm just dividing by 2. All right, I got 63. Okay. Right off the bat, what's the square root of 2 times 2? That's going to be a 2 out front. Now I'm going to keep going with my 63. 7 times 9. Oh, what's the square root of 9? It's a 3. Can I do anything with the 1, 7? No. See how my 7 is left in underneath the radical, right? Isn't this still under the radical? So final answer, 6 times the square root of 7. That's what your work should have looked like if you're understanding. Let's do the 80. 4 times 20. Now already the square root of 4 is 2. I get a 2 out, right? Now watch again. 4 times 5 for the 20. What's the square root of that? 4, a 2. Or I could have at one time done the 2 4s, right? You see, either way. So it would work either way. And what's left in? The square root of 5. So final answer, 4 times the square root of 5. And again, that's how your work should look. Next page. All right. Pay attention on these. So we talked about SBUM, simplify before you multiply. Remember, to take the root, you need 2 of the same factor. A 6 is a 2 times 3. And a 30 is a 2 times 10, and the 10 is a 2 times 5. Now watch. 1, 2, 2 2s. The square root of 2 times 2 is a 2. 1, 3, 2 3s. The square root of 3 times 3 is a 3, right? Because that's a 9. Square root of 9 is 3. And what's left in? Square root of 5. And that's why the answer is 6 times the square root of 5. That's what your work should look like. Okay, on this one, notice first off we have 3 times 2 is 6. And now we're going to start doing the radicands. 2 times 5, 3 times 5. By the way, notice every time I factor, I cross off what was there because it's now become, the 15 has now become a 3 times 5, right? This is important that we're following along like this and following this, okay? Really important. Okay, let's keep going. Oh, I've got a 5 times a 5. And the square root of anything times itself is that number. And I have 1 2 left and 1 3, which is a 15. So that's why 34 is 30 times the square root of 15. How do you do 35? The square root of 36, you might be tempted to do 6, but now that's going to leave you in trouble. In this one, it works better to do 36 divided by 2, or the square root of 18, and now we simplify the square root of 18. This is 2 times 9. What's the square root of 9? 3. And what do we end up with? 3 times the square root of 2. Now, if you did it the other way, let me go back here. If you were here, okay, I'm trying to remember if we dealt with rationalizing the denominator. If we did, you know you have to multiply the bottom by a square root of 2, and whatever you do to the bottom, you do the same thing to the top. Notice how we end up with the top being the square root of 6 times 2, and what is the square root of 2 times the square root of 2? That's a 2. And now when you reduce this, don't you also get 3 times the square root of 2? You do. That's how your work should have looked. 36, the key here is to split it up in the square root of 25 over the square root of 121. What's the square root of 25? We all know that's a 5. What's the square root of 121? We all know that's 11, and that's how you get to 5 over 11. All right, almost there. Let's see, 37. So watch what happens here. So you get a couple things going on. You can right now reduce the 3 and the 6. They're both outside the radical. So here's where I'm at right now. Square root of 8 over a 2. But I need to factor this 8 to see if it simplifies. And it does. Notice how I can get a 2 out right there. So let me be clear. Here's where I'm at right now. My top is 2 times the square root of 2, and my bottom is a 2. And do you see how those 2's divide out, leaving the final answer of the square root? That's why the final answer is the square root of 2. And I got to tell you, students, honestly, now look, let's be honest. When you go from this right to this, I'm thinking you probably got the answer from the answer sheet or from the internet. If you're not showing me this step, I don't think you're understanding what's going on, and I don't think you're actually doing the problem. So this is important that we learn how to do the math. I know this sounds weird, but finding the answer on the internet or getting the answer from the back of the book doesn't help you if you don't know how to get that answer. You got to figure that out. Okay, 38 is adding like terms. Did you catch that there's one of those? So watch. 7 positives and 3 negatives is 4 positives. 4 positives and 1 positive is 5 positives of them. And what are the thems? Square roots of 3. That's why the answer is 5 times the square root of 3. All right? 39. We can only add these 2 up. They're the only square roots of 5. And again, 9 of them and 1 of them is 10 of them. And then we still have negative 6 times square root of 7. Can't add them up. They don't add. All right, did we do 40? We did. Last problem? Woohoo! All right, last problem. Here we go. 2 times the square root of 50. All right, I got to simplify the square root of 50. 2 times 25. What is the square root of 25? I get a 5 out. So watch, in the front now, 5 times 2 is 10 times the square root of 2. All right, 72. Oh boy, what times what? 8 times 9 is 72, right? 9 times 8 is 72? Yeah. All right, I'm getting a 3 out. Here, I'm going to, watch, I still have this negative. Right now, I just got a 3 out, and I got to keep going out. Oh, didn't cross out my 72, need to do that. Right, and now my 8 is a 2 times 4, and can I get square root of 4 is a 2. So here's where I'm at. 10 times the square root of 2 is the front, minus 3 times 2 is 6, times the square root of 2 is the back. Now, they are like terms. 10 of them minus 6 of them is 4 of them. All right, class. Some math, some radicals. Important chapter. As your math goes forward, you'll see radicals quite a bit, and hopefully we laid a good foundation this chapter. We're almost to the end, so hang in there. Again, quiz and test coming next week, and we'll continue on, and we'll get there, and we'll get you your education, and you guys will be learning. You know, honestly, a lot of students right now, all they're doing is review work, and they're going to miss a quarter of their year. But you guys, you're going to get your full math education here in pre-algebra, and we're going to get you there. We'll streamline it a little bit for you, but we're going to get you there. Hang in there, and this will come to pass. It shall come to pass. Trust in the Lord with all thine heart, and lean not unto thine own understanding. In all thy ways acknowledge him, and he shall direct thy paths. The Lord's in control, and we just need to trust him. All right, have a great day. Look for my emails and the other materials coming. All right, bye.